Hello, and welcome to today's tutorial on creating pile plans in Trimble Business Center. Let's begin. We will start off today by creating a new project and selecting our unit template. We will be using the metric template, but feel free to select your preferred unit of measure. Once your new project is loaded on screen, the first step we will do is to ensure we are on the correct coordinate system. This menu will be located on the bottom right of your project. It should say Default. If you have a calibration file provided by a customer, you can import it at this stage instead of selecting a coordinate system. For this demo, we will be using the coordinate system that is used on the Westminster, Colorado test pad at Trimble's headquarters. When the Project Settings menu opens up, you want to make sure you have the Coordinate System tab on the left-hand side selected. Once we are in the correct location, we will want to navigate to the bottom of the screen and press the Change button. Keep in mind you will need a field data license to access this feature. We now have a few different ways to look up our coordinate system. If you know the IDs or name of the system you wish to use, select the Search By option and start typing. For today, we will use the Coordinate System and Zone Lookup tool. We are looking for United States NAD 83 for the system group and Colorado Central 0502 for the zone. When selected, you will then be asked to select a specific geoid to use. For this demo, we will select the No Geoid option. Once selected, we can now view all of the EPSG IDs from your selected coordinate system. If someone is asking for specific IDs, you can find them again in your project settings under the Coordinate System tab. We are now ready to import our starting ground point. Go ahead and drag and drop your CSV file into your project, or use the Import function under the Home ribbon. Ensure you select the correct import format. Keep in mind the order of your points, northing, easting, and elevation. Are they PNEZ or PENZ? If there is an existing import format, go ahead and select that. If you have a custom CSV format, feel free to create your own importer by selecting the New option on the top right of the pop-up window. We want to be able to manipulate our starting ground point, so that means we need to import our point as a grid-only point. This allows us to change the elevation of our starting point without having to create a new point on top. Make sure to select the Import as Grid-Only Points option under the Select General Properties window. If you see any import errors, feel free to review them. Most of the time, this error message will pop up when there are extra items or columns in your CSV that TBC is ignoring or not in the expected format. We should now see our point or points on our main project window. An optional step: if you are signed in with your TID login information, you can use the Trimble Maps Satellite option to ensure your points are in the correct location. Let us now verify our point information. If you right-click on one of your points and select Properties, you should see a tab open on the left-hand side of your screen. Here you can scroll through all of the northing, easting, elevation position information, as well as the calculated local and global coordinates. What we are looking for here is to make sure the elevation matches what the customer is expecting. As you can see, our grid coordinates are labeled blue. This means we can directly edit information here. We can change our elevation directly here to match our requested top-of-pile elevation, better known as cutoff elevation. We will be using the Change Elevation command found under the CAD ribbon, or under the CAD section of the Drill Pile Compact ribbon. You can also type in the command under the search pane after pressing F12. Once we have the Change Elevation command open, select the point you wish to manipulate. Our customer wants a cutoff elevation of just 4 feet above the ground point. For this, we will enter a delta elevation change. We can go ahead and type in 4 feet with the unit denoter FT in order to convert directly to your project's unit template. After hitting Apply, you should see the delta elevation change in the converted units, about 1.219 meters in this case. We have now defined our cutoff elevation and are ready to create rows for our pile points. For this tutorial, we want to create 3 rows going from west to east. Since we ultimately care about the top of the pile, we want to create a line for our rows that has constant elevation. For this, we will use the Polyline command under the Create and Edit section of the Drill Pile Compact ribbon. Let us name our line. Let's create a layer for our rows by selecting New Layer under the Layer drop-down menu. Now is a good time to create layers for your rows, pile points, and pile plan. This will help with exporting later. Select the Elevation tab and click on your starting point to populate the field with the proper data. Now select the next point field and again select your starting point. Now that we have our first point selected, ensure you have the Snap Ortho mode turned on. This toggle is found on the bottom of your project window denoted by a right angle icon. Now you can click anywhere on your project map to denote the second point and create your line. Make sure to press the Close button on the Polyline command pane after you have specified the second point and see the line generated on screen. It is now time to create our second and third row. We will do this by using the Offset command to offset our polyline a specific horizontal distance. We will begin by naming our new rows. Select the row layer we created in the previous step. Choose the line to offset and specify our horizontal offset distance and direction. We can now hit Apply and see the first offset line get created. Every time you press the Apply button, you are offsetting a new line based on the recently offset line. For this tutorial, you will want to press Apply twice to create our extra 2 rows to have a total of 3. Now that we have created our pile rows 15 feet apart, it is time to create our pile points. We will do this by using the Create at Intervals CAD command. You can search for the command in the lookup panel after pressing F12. We can now follow the prompts on the Create at Intervals command pane. You can select all 3 of your rows to do this all at once. You can either highlight all of your rows or click on the Options button and select by Layer option to select just your rows based on the layer organization we specified earlier. We can now enter our interval. For this tutorial, we want our piles 15 feet apart. After setting our interval, create your pile point layer if you have not done so already. We do not want any horizontal or vertical offsets, so leave those at 0 and hit Apply. You should now see all of your points generated on screen along the rows recently created. Unless your row lengths are divisible by your pile spacing interval, it is a good idea to remove the endpoints. You can verify that the rest of your point distances match using the Measure Distance tool under the Home ribbon. It is now time to start the pile plan creation process. We will begin by creating or managing our pile types. You can find the Manage Pile Types command under the Drill Pile Compact ribbon in the Piling tab. If you are in a new project, the Manage Pile Type window should be empty. We can go ahead and click on New to create our W6x9 I-beam pile type. A W6x9 I-beam has a depth of 5.9 inches and a width of 3.94 inches. For this tutorial, we will be using beams cut to 8 feet in length and want an embedment of 4 feet. This means that in an ideal scenario, if our land was completely flat, each cut-off elevation will be exactly half of our piles. Since this is not the case, we need to specify a minimum embedment as well. This defines the minimum allowable depth needed to drive these piles into the ground to reach our desired cut-off elevation. Let's use 1 foot as our minimum embedment for this tutorial. Next, make sure you select the correct cross-section shape. We are working with I piles, so our cross-section will be an I. It is a good idea to name your pile the type you are working with. In this case, as we have stated previously, this is a W6x9 I-beam. The rest of the parameters are going to be specific to your job site description. You can enter tolerances based on those details, but for this tutorial, we will leave the default values. We can go ahead and click OK and close the Manage Pile Type window. We are now ready to create our pile plan. Go ahead and click on the Create Pile Plan button under the Piling section in the Drill Pile Compact ribbon. We can now name our pile plan. Then, select our pile plan layer or create one if you have not already. And finally, enter our plan tolerances. We will leave these default for this project. Once your pile plan is defined, we can now create piles at the points we created earlier. Navigate and select the Create Piles at Points button in the Piling section of the Drill Pile Compact ribbon. Next, select the pile plan you just created, and now move down to the Selected section. Press Options, select by layer, and only check your pile points layer. Once you select the correct layer, you should see only the points you created selected. If you know the number of points you created, double-check the number under Selected Matches. Now we can select the pile type we created in a previous step. We are now ready to hit Apply. If done so correctly, you should now see your piles under the points we created along the pile rows. Zoom in to check that your pile geometry looks correct. You can also click on the 3D view in the Home ribbon to check pile placement on a surface if you have one loaded. Now that we have our pile plan, let us export it using the VCL link exporter format under the Construction tab in the Export command. We can now go to the Select window and do the same step as we did when creating piles on points. Select Options and select by layer, and then select your pile plan layer only. If you want points or surface data within the VCL, make sure to select those as well. For this tutorial, we will only be exporting the pile plan itself. Now go ahead and click on the three dots to the right of the file name. This will open up your file browser. Select the location you wish to export the pile plan to, name your file, and afterwards remember to hit Export. Once the window is closed, you should be able to see your VCL in the location you specified. Thank you for following along today's tutorial on creating pile plans in Trimble Business Center.